We are doing Dmr F number 2. I have reverted to go into the computer so that you guys can see how to type these prime factorizations. You should have completed yesterday's Dmr 1, and so we are working on Dmr 2. I'm going to make it a little, whoops, wrong way. Make it bigger so that I can see it a little easier. Our prime factorization for... I love it when it does this for me. Sorry. There we go. Prime factorization, we should have listed all the prime numbers. And in this case, I know the first prime number that this is divisible by with 24 is 2 times 12. Well, 2 is a prime number, so I'm going to underline it instead of circle it because that's what my option is. But 12 is not, so I'm going to continue on. That 2 stays there because 2 times, and now I'm splitting the 12. I can factor 12 into 2 times 6, and I'm going to go back and underline. So this 2 comes from here. It stays the same. But this 2 times 6 comes from this 12. So I'm going to underline this 2 because it is also a prime number. But 6 is not a prime number because I can change that. It's not just 1 times 6. I can write that a different way. So I'm going to bring down my 2 times 2. But the 6 can be changed. It can be factored into 2 times 3. So I'm going to rewrite that 6 as 2 times 3 instead. And remember, this 2 came from up there. It's the same. This 2 came from here. It's the same. But this 2 and this 3 came from the 6. And 2 is still prime, and 3 is also prime. So at this point, now that I have all of my numbers underlined stating they are prime numbers, I am done. And this is my complete answer. 2 times 2 times 2 times 3. Well, we know that we can write that 2 times 2 times 2 as 2 to the third power. And I do that by saying 2 to the third power. I'm going to highlight the 3 and say format, text, superscript. But then I have to click off of it and do it again. Format, text, superscript, and it'll make it big again, times 3. So this 2 to the third is reflecting these, and this 3 is reflecting this. So if I multiply all that out, I will get 24. That is prime factorization. I know that if a number can be factored by more than just itself, it isn't prime. Let's go to the bottom. We're doing the fraction of the shape that is shaded. So the first thing I want to do is count the numbers in the whole. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 9 is my denominator. The whole has 9 parts. The denominator. The shaded has 4 parts. This is the numerator. So to write that answer, you put the part, which is 1, 2, 3, 4, over the whole, which is 9. And that solves that.